So we'll start with relative position vector, no? That we have seen slightly of that thing before also, but still I'm going to start with this. Suppose if I happen to know position of point A, which can be a moving point also, and I happen to know the position of the point B. Suppose the position vector of the point A is RA and the position vector of the point B, let's suppose RP. Then the vector which is starting at A, ending at B is telling us how to reach B from A. No? So that arrow, which is, I can call him as AB arrow, is starting at A and terminating at B. So this arrow is going to be locating the point B with respect to A. So from wherever we locate some another point, that will be our reference. No? So if I ask you what is the position vector of the point A, so what really position vector means? The position of the point with respect to the origin. So in that case, the origin is the reference. So reference is going to be at the tail of the arrow. No? So for writing the position vector, the tail is the origin and the head is the point, the one I want to locate. Same way, if I say position of B with respect to A, so in this case, who is acting as a reference? A. So the tail will be at A and the head will be at B. So arrow AB is telling us position of B with respect to A. And that is also written as RB/A. Now, if I draw the arrow of the one which is BA, so if I wrote this arrow, it is terminating at A, starting at B. So I can write him like BA arrow also. It is going to be telling us the position of A with respect to B. And the way to write this thing is RA/B. So what you will see, the arrow which is AB or BA, both are of same length, but they are in exactly opposite direction. Maybe I'll draw another color for him. So you check out the arrow, which is red one. It is the position vector of B with respect to A. The blue one is the position vector of A or position of A with respect to B. Now, in case if I happen to know the position of A and B, how come we might be knowing it? Maybe if I give you a case, suppose if I tell you the coordinates of the point A, X, A, Y, A, Z, A, and if I tell you the coordinates of the point B, X, B, Y, B, Z, B, in such case, we will know how to write the position vector of the point A, which is RA. So RA totally you can write down, no? That will be XA I cap plus YA J cap plus ZA K cap. Position vector of the B, same way you can write it down as XB I cap, YB J cap, and ZB K cap. I'm not using mic right now. Maybe I'm not using earphone right now. If I use a earphone, the sound is better or like same only. or what's it's a cheap earphone. I don't know whether it is going to sound okay or not. So now the sound is like more easier to understand, or earlier it was more easy to understand. Okay. Now the thing is, I want to know the RBA or RAB. So maybe I will use triangle law vector addition. So whichever way you are comfortable to apply that law, you apply in that manner. First, I'm drawing the figure here. This is OA. OA is the position vector of the point A. And this is AB. Now, in this triangle OAB, you will find OA and AB are in tailhead arrangement. So sum of these two will be given by this one, no? So I will write down OA plus AB. Tell me in OA and AB, when I write A is sandwiched between O and B, no? That is going to be giving us OB from triangle law. And what is OA? RA. And what is AB? So if I don't draw the arrow of AB, just you see the text AB, what you find? B is the head, no? So where we reach B, from where we reach B from A. So that is position of B with respect to A. And that is OB equal to OB and OB is RB. So from this thing you will get RBA will be equal to RB minus RA. Same way you can find RAB also. But if I know RBA, I don't have to do anything to find RAB, no, because RBA and RAB are of equal length, but they are in opposite direction. So RAB is minus of RBA. From this itself, I can find that RAB is going to be equal to RA minus RB. I hope this thing is clear to all of you now. If I replace RA with this and RB with this, I can write it down like this also. XA minus XBI cap plus YA minus YBJ cap and ZA minus ZBK cap. I hope these things are like clear to everyone, no? So copy this thing fast, or don't copy. I'll share this thing, but after the class, you must copy. I will check whether you have copied or not in class. Okay. Okay, I will take a new page. Yes, some of these things were told earlier also. So it's not like a very new thing to you. If new also, I have told everything. So this relative position vectors, we know what it is. Now next is relative velocity vector. So RAB is going to be RA minus RB. Where I'm measuring the position of A and B. So where RA and RB are the position of A and B with respect to origin, and suppose that origin is in ground free. Okay. So this RA and RB are the position vectors of A and B with respect to the ground frame. So RA is the position vector of A with respect to the ground frame. And RB is the position vector of B with respect to the ground frame. Now, if I do the differentiation on either side, what we get is differentiation of RAB, what really you will be writing him down as. So rate of change of position of A with respect to B must be giving us velocity of A with respect to B. Rate of change of position of A with respect to the ground frame, no? With respect to T, but RA is the position vector with respect to the ground frame. So that is the rate of change of position of A with as seen from ground frame. What I must write down as VA. By that we mean velocity of A from ground frame. Same way this will be VB, velocity of A with respect to ground frame. These are the velocity, is the velocity of A with respect to ground frame. Same, this one is also. Now again, if I perform differentiation on either side, what I get is accelerations. No, that acceleration of A with respect to B will be acceleration of A minus acceleration of B. Now again, same like earlier, the velocity of A with respect to B is going to be negative of velocity of B with respect to A. And the magnitude of these two vectors will be equal. Same way, acceleration of A with respect to B is going to be negative of acceleration of B with respect to A. And the magnitude of these two vectors will be equal. Now, one category of questions will be where velocity of A and B given. Okay. And maybe you have to find velocity of A with respect to B. So in that case, you will be finding the vector sum of VA vector and the vector which is minus VB, no? So one kind of questions will be like checking whether you know vectors or not. In that case, they might give you VA vector this, VB vector that, and maybe angle between them given. So it's going to be same like asking you find A minus B vector when vector A and B are given, not minus B. Okay. And the angle between A and B is given, not the angle between A and minus B. I hope that thing all of you know it now. So in case if I have to find out VA minus VB vector length, just to tell you that don't forget vector things can be used here also. It will be VA square plus VB square, no, minus of 2 VA VB into cos theta, but we must be careful. In this formula, theta is not the angle between VA and minus VB, under quotes minus VB. It is the angle between the vector VA and VB. Same way, it could be asked find what is the length of the vector acceleration of A with respect to B is. Same thing you will do A acceleration of A square plus B square. Just don't forget the vector things can be used here also to figure out few things. In here, I'll be using some angle that will be the angle between the acceleration of A and acceleration of B. Okay. I hope whatever done in this slide is like all of you have understood. I'll give you a few seconds to have a look and then I will take a new page. Okay, I can take a new page now. Anyone having any doubt? Okay, then I'll take a new page now. In case if anyone wants me to return to this page, you tell me. Phase 3 students, man, understood now? Or phase 3 students only did not came?
Phase 3 are here, sir.
Here, no. Now, next is, see, basically what really we have to learn in this chapter is that what kind of mindset or what kind of thought process you will have whenever you're observing an object by being in the frame of another object, which is a moving object. Maybe moving with velocity only, or maybe moving with changing velocity or acceleration. So maybe I'll take a simple question of Sivarma. Try to tell what kind of thought process you will have. I know the question, just I want to show you. Police inspector in a jeep is chasing a pickpocket on a straight road. The jeep is going at its maximum speed v, which is constant. The pickpocket rides on the motorcycle of a waiting friend. The jeep is at a distance d away. The motorcycle starts with a constant acceleration a so that the pickpocket will be caught if v is more than or equal to 20. So when jeep, pickpocket is like so difficult words to pronounce. So I will call them as A and B. And I will draw the situation. I'll write down the situations that is given at the starting. That I'm going to call it as t equals to 0. Suppose first one is G, that is suppose A. Second one is that motorcycle guy, that is suppose B. So what is given is at t equals to 0, the separation that is between them is t, and 1D motion it is. And the jeep, that is A, is moving with constant velocity always. So it is moving with constant velocity that is given. That velocity of A is v, and that is not changing, it is constant. And that's why what is the acceleration of a is 0. Now b is having initial velocity. To write, to do kinematics, what all things always we'll be looking for: initial position, initial velocity, and acceleration by default every time. There is a thing that those are the things we will be interested in if it is a question of kinematics. No? So initial velocity of B told it is at rest. You should know what data you must extract from the given story. Next, it's told that he is moving with an acceleration. Now 1D motion, we use plus minus for telling directions. No. So suppose if I consider that the side in which they are moving along, that is in the positive direction. And that is the reason why I wrote the velocity of A, the initial velocity or the constant velocity with which A moves, to be plus V. No? I'll mention that plus V. The same way, he is moving in the rightward direction with an acceleration A. So the acceleration of B, I will write down as plus A. And they are asking us prove that B will be caught up by A, or A will catch B only when V is more than or equal to 280. So maybe I will solve it from the ground frame first. So this is the situation told to us at t equals to 0. So I'll draw a separate figure for it. Right now at 0, the separation that they have between them is t. And after some time, this is the position of A at t equals to 0. And this is the position of B at t equals to 0. And to solve it, we will assume maybe A catches B after some time. And suppose the time when A catches B is suppose t. Now, at time t, A and B are at same location. So if I ask you in time t, how much the displacement B has undergone. So B has undergone this much displacement, no? So I'll write down as SB, the displacement of B. Now, in the same time in which B has traveled that much, how much the traveling A has done. So this much is the displacement of A, and the initial separation that they have between them, that is t, no? So I will write the equation which is going to be true, when A catches B. So when A catches B, the displacement of, I'll write that thing maybe where here. Just a moment, I'll make this question smaller. When A catches B, the equation that will be true will be this equation, that displacement of A is going to be same as displacement of B plus T. All of you agree to it. Have a look at the figure. How much the A has traveled, this black arrow, and how much B has traveled, this blue arrow. So length of this black arrow, is it not equal to D, the initial gap or separation between them, and this blue arrow? So displacement of A is equal to displacement of B plus D. Now the nice thing is the motion of A is with constant velocity. So in time t, how much displacement he will undergo? Velocity into time, no acceleration he has. So that will be Vt. And displacement of B will be ut plus half at square I'm going to use. But what is the initial velocity B has? 0. So ut term gone, we have only half at square. So displacement of B will be half at square plus t. Correct. Now next thing is, maybe just I will simplify it. So I can write it down like this. At square minus 2vt plus 2d is equal to 0. So up till here, whatever we have done, I hope all of you have understood. Because here physics gets over. All of you understood, no? These three students understood, no? I can't tell your names because like Motorola, one guy's name is.
Understood, sir.
Okay then.
Yes, sir. Understood.
No. Next comes the math part. That if A catches B, then this black equation must be true. So this must be true. So suppose if I have equation x is equal to y. So if I write like him like this, x minus y equals 0, both are same thing only, you're not. You can't say like x equals to y is different from x minus y equals 0. Both same only.
சும்மா அட்டைன்மெண்ட் வாடா என்னமா நினைச்சிட்டு இருக்கீங்க
Okay. So this equation should be true. So this should be also true. This equation being true means what? LHS should be equal to 0. And LHS can be equal to 0 since it is a quadratic only when it can have real roots, no? Or possible values of the t. Correct? If I get a value of t which is like root over minus 5, not possible. Such t not possible. So it means this equation will not be becoming equal to 0. So for this thing to be equal to 0, it should have real roots. So that is something I hope everyone knows. And if I give equation ax square plus bx plus c equals to 0, to have real roots, what is the condition is b square minus 4ac should be more than or equal to 0. Same thing I will do there. B square minus 4ac will be minus 2v square minus of 4 into a into 2d should be more than or equal to 0. So 4v square will be more than or equal to 4a into 2d. So v should be more than or equal to root over 280. I hope all of you have understood it. That quadratic thing also. Okay. Have a look. I will take a new page and then maybe I will be solving it by being in the frame of it. Once you have done checking it out, you tell me. I will take a new page. I hope everyone has joined from like big screen. In case if you're joining from phone, maybe if possible you cast your phone to TV or something. Don't watch it from small screen. Feels like insult of the subject, man. Like correct, and maybe you will not be understanding it in proper way. It's not like some thoughts you're watching on phone, no, and should feel like you're doing some study thing. Psychological reasons are also there. So always join online class if it is there from big screen only. If not possible, then no problem. Not possible, then some it is good to join from something, then from nothing. If possible, then you do whatever can be done. And okay, again take a new page now.
Yes.
So if I solve this question by being in the frame of A or B, kind of mindset we have, maybe I will try to write it down even. On observing from A's frame, now tell me to discuss or to do kinematics things. The things that we need is initial position, the initial velocity and acceleration. So now I'm observing B from the frame of A, what we will think. So the mindset will be the same as solving a question. Question doesn't sound nice. Solving a problem in which A is a fixed point and B is the only moving point, but comes this big but, moving with, moving with relative parameters. Means what you will do, relative parameter means everything which is relative. Okay. So if I have to decide what kind of thing we will be doing in future, so what all things I must know, that what is the position B is having at t equals to 0. What is the velocity B has got at t equals to 0. And there on afterwards, what is the acceleration B is having. So you think you're solving a question in which A will be not moving at all, and really A will not be moving, no? Because if I ask you what is the velocity of A with respect to A, that will be 0. What is the position of A with respect to A? That will be 0. So literally we'll be thinking A is a fixed point and it is the origin as well, fixed point and origin, and B is the only moving point. So you you will write down everything for A00, but for B, initial position I'll write down here, then what all things we need, initial velocity, and what else we need, the acceleration. So you consider taking a case where everything of A0 and provide B with whatever things that you see for B by being in the frame of A. So position of B, initial one will be initial position of B with respect to A. So I'll write down as RBA initial. How to find it out? In general, it will be position of B initial minus position of A initial. No? Then what else you need? Velocity at t equals to 0. So we need, so U symbol we use for initial. No? So we'll be needing initial velocity of B with respect to A. And how to find it out? Velocity of B initial UB minus UA, and acceleration will be the acceleration of B with respect to A. How to find acceleration of B minus acceleration of A? So it is like converting a one body question, no? In which A and B. So if I observe it from ground frame, we will find both A and B are moving, and I have to solve a problem where two bodies are moving. Now, if I sit and observe by being in the frame of A, it becomes a question in which A is not the moving thing, only B is the moving thing. And it is moving with what all things? This all things. So it's sort of we are converting a two body problem into one body problem, no? And generally, one solving one body problem might be like more easier than solving two body problem. Correct? I hope whatever I've written here, it is making sense to all of you. And if, in case if you have confusion that why those things became zero. So initial velocity of A with respect to A will be what? Initial velocity of A minus initial velocity of A, what you expect it to be? Zero only, no? So everything of A will be made equal to zero, and everything of B will be made equal to relative. When you think as if A is a fixed point, maybe in ground frame only, and B is the only moving point, but moving with this all, then how to solve that brand new question to get the answer for the earlier question? So it's like solving a new question to get the answer of some another question. So when I sit in the frame of A, you should be like sort of disconnecting yourself from the earlier question. Think as if you're solving a new question to avoid any confusion. So have a look in case if you're copying whatever. Tell me when to take a new page. All of you understood, no?
Yes, sir.
Hmm. I'll take a new page now. So 1D motion, things are simpler that I have to use plus and minus to tell directions, no? So what is given is A is moving this side with constant velocity, and we have done rightward, we have taken rightward as positive, no? So first job will be, so literally I will think A is the origin. So this is suppose our x is equal to 0. So this will be given how much x is equal to plus t. At t equals to 0, I'm writing down the things. So first job will be to find the position, no? So initial position. I should write down initial relative position. So that will be position of B minus position of A. So here only x position we have, so x of B minus x of A, that will be D minus 0. So we got it as plus D, plus telling us that rightward, no? Now initial relative velocity. That will be initial velocity of B minus initial velocity of A. And what is initial velocity of B is 0, and A is having plus V, no? So 0 minus plus V will be how much? That is going to be minus V. So minus telling us he is moving leftward, but with what speed? V. Next is relative acceleration. So relative acceleration will be acceleration of B minus acceleration of A. Acceleration of B is plus A minus 0, so we get plus A. So plus telling us here that it is rightward. Now we have framed our thing. To explain it is taking time. To solve it will not be taking that much time. So at t equals to 0, I will draw the things. I will think A is fixed, not moving. This is our A, fixed, not moving. And where B is located? At a distance D in the rightward direction. So this is the position of B at t equals to 0. And with what velocity B is moving is V, but leftward direction. And what is the acceleration A has? A, which is in rightward direction. Correct? So this is the new question that you have to solve. That particle B is made to travel or is starting to move with velocity v leftward and acceleration rightward. Now I can get the same answer by doing something else also, but I want to arrive at the same equation, the one that we got it from ground frame. So at time t, if B is going to reach at A, then how much displacement B will undergo with respect to it. So literally you can tell, no, A fixed, not moving, that is suppose our origin, and B moving in negative x direction. Initially B is where? Initially the B is at location plus t. And finally when B arrives at origin, what is the final position of B will be? Origin. So 0. Initial position of D, initial position of B, not D, what D? Initial position of B is plus t. Final position of B is 0. So B is only moving. So when B arrives at the place of A, and what is that A place is? Origin. Then the final position of B will be 0. So displacement of B just a moment. I want to tell one thing before it. So whenever you are observing something from some another frame, still same equations of kinematics will be valid. Suppose if you come across a case when acceleration relative one is constant, then whatever results those were applicable, same will be applicable again. Just we will be using the relative terms in every those equation. For example, if A constant, we can write V equals U plus AT. So here also I can write, just I will write final relative velocity is equal to initial relative velocity plus A relative into T. Same way S equals UT plus half AT square was valid, so same it will be valid now also. S equals U relative T plus half into A relative into T square. Then what else over there? V relative square will be equal to U relative square plus 2A relative into S relative. And one more was there, no? Average velocity one. And one more was there, displacement in another second one. So same one I can use again. Just every term will be a relative term. Like the case that here we have, what is the acceleration relative one? I got it here. Plus A. Plus A minus A doesn't matter. It is a constant one, no, with respect to time. So here I have that case where the acceleration of B with respect to A is a constant thing. Since acceleration of B with respect to A is constant, so I can use displacement of B. See, got the point now. I'm using S equals, I'm writing S equals UT plus half AT square. But whose displacement we are observing? Displacement of B from which frame we are observing? From the frame of A. So every term will be the thing that we see for B with respect to A. So displacement of B with respect to A will be initial velocity of B with respect to A into T plus half of acceleration of B with respect to A into T square. So you do one thing, you replace, so whenever B arrives at the place of A, displacement of B with respect to A, we know what it will be. Final position of B with respect to A minus initial position of P with respect to A. And how to find this thing? That is easy. Literally, I'm thinking A not moving, and initially where B is located at location which is plus T. When B arrives at the place of A, which is origin, where he is at origin means 0. So initial position is the final is 0. So 0 minus T. So displacement of B with respect to A is minus T. And you don't have to do that much hard work also. Tell me, B starts from here. Literally, we are thinking a new question. B only moving. B starts from here, arrives here. How much he has traveled? What length it has traveled? T. In what direction it has traveled? Leftward. And what is leftward is negative. So displacement that B has undergone is minus T. So after that, we'll plug the values of everything in this equation. What we get? Minus T. What is initial velocity that B has got with respect to A? Minus V. So minus Vt. What is the acceleration he has got? Tell me. At, no? A, no? So half At square. So just you write down everything on one side. It will give us At square minus 2Vt plus 2D is equal to 0. Now, check out this equation and check out the old one, the one that we got it from the ground frame. Both are same or different. At square minus 2Vt plus 2D is equal to 0. Correct? But the final answer is this. So to get that final answer, maybe when solving from the frame of A, I will not be writing this equation. The end goal is to find this answer, no? So let's find this answer without writing this equation also. I hope this thing is clear to everyone. That equation that we got here, same as the one that we got it from the ground frame, no? I hope everything is clear up till here, no? All of you understood now what really
Yes,
will everyone needs. Okay. So how to solve it maybe without using this equation? So tell me, suppose here I have an object thrown upward with speed u. If I ask you, find minimum u so that it reaches height h. Any idea? So the job is for him to reach maximum. Job is to reach at height which is h. That is the only job. And we have to throw him with minimum possible speed. So what it will be? The speed for which his velocity should become 0 when he is at that height or not. So I can use v square equals u square plus 2as. I hope you got the point. Now the minimum speed of projection will be the one for which he is just able to reach there. So when he will be just able to reach there, when his speed becomes 0, just the moment when it reaches there. So for that speed of projection is going to, so that speed of projection for which the speed becomes 0 at this height is going to be the minimum speed for which it is going to reach that height. So V0, so 0 equals u square minus 2gh. So what will be u? U square is 2gh. So u will be root 2gh. So for crossing the height h, what I will answer, u should be more than or at least equal to 2gh, correct? So this thing is like simple thing, all of you understood it. Same concept here also. So don't forget we are solving a new question where A is origin not moving, B only moving. And tell me, with what velocity B started with? V. But what acceleration he has opposite to the velocity? So what will be happening to the speed of the particle B? Will be getting reduced, no? Same like this or not? When I throw him upward, the velocity he has at any moment is upward and acceleration down. So his speed reduces and becomes zero after some point of time. Same way here also. Our job is to make him reach D, no? At the point A, no? So it means the minimum speed V for which it reaches A is the one for which his speed becomes zero when he reaches A, correct? So it means you're solving a question where, and maybe I will take anything you can take. Maybe if you want to stick to the same sign convention, you stick to the same sign convention, positive this side. So I will use V square equals U square plus 2AS. So V0, same thing I'm using, V0, U is V square minus V square, but minus V square. What is the acceleration it has A, and what displacement it undergoes when it reaches there minus T. So the minimum speed will be V square equals 2AD. So the minimum speed is root over 2AD. So what is the, I will write only when B reaches A, when V is more than the minimum possible speed, which is 280. I hope all of you have understood by this way also. Literally, we are solving a new question or not? All of you understood, not the mindset that you're supposed to have.
Yes.
Okay, then. So maybe I'll leave it for a minute, few seconds, then tell me when I can take a new slide. I'll take a new page now.
Yeah.
The next thing is finding out the rate of change of separation between two moving particles, or rate of change of distance between two moving particles. So maybe I'll start with simple question. Rate of maybe I'll start with a simple case. Suppose it is given particle A is moving with velocity v1 which is equal to maybe 5 meters per second at any given instant. At same instant, B is moving with V2, but with 3 meters per second. And both of them are moving in the same direction, or the velocity of both of them is lying entirely along the line joining them. And at this given moment, I have to determine at what rate the distance between them is changing. We call it as L. So at this given instant, I have to find dl by dt. So what you can do is maybe you can sit in the frame of A or B, whichever you like. But maybe A is like more easy to draw for me. Left side he is, so I will sit in the frame of A. So from A's frame, what is the velocity B is going to have? Maybe you can do like this also. So this is our plus x direction. So what is the velocity of A is v1 I cap. I don't have to use I cap, but still I'm using it. And what is the velocity of B will be? Or what is v1? 5 I cap. Write that only. VA is 5 I cap. PB is 3J cap. So sitting in the frame of A, I must know the velocity of B with respect to A. So velocity of B with respect to A will be VB minus VA. And VB minus VA, if I do, we get 3 I cap minus 5 I cap. What I wrote in J cap, right? I cap, no? 3 I cap minus 5 I cap, that will be minus 2 I cap. It means by being in the frame of A, we will find B to be moving with speed 2, but direction in which he moves is leftward, because rightward we took it as plus x. No? Now it becomes a new question in which A not moving and only B moving. But with what rate B is moving or with what speed B is moving is 2, but in the direction which is leftward. No? And the velocity that B has with respect to A is 2 in leftward direction. Now, literally, you think you have a new question in which B only moving, A fixed, and at any given moment, if I tell you the distance or the separation between them is L. So see, A not moving, maybe A is fixed and maybe take it as origin. Maybe that is a point on the origin and B is a point on the x-axis moving towards the origin. So, and it is moving with what? 2 meters per second. So if it is moving with 2 meters per second, it means in 1 second, see how much he travels? 2 meters, but which way he travels? Leftward. So in 1 second, the distance between A and B reduces by 2 meter or not? I hope all of you agree. So much noise. Just a moment, I'll close the door. Do you hear any noise? Maybe not.
No, sir.
Okay, then. This paid subscription has that noise cancellation thing. So in 1 second, the distance between A and B reduces by 2 meters. So what is happening to the distance L? Is it not reducing? And in 1 second, how much it is getting reduced by 2 meters? So what will be the rate of change of this quantity negative? Rate of change means how much it changes in 1 second. So it is reduced by 2 units in 1 second. So what will be the rate of change? Got the point, no? It's like 10 rupees 5 chocolates. 1 rupee, how many? Rate of chocolates, no? So same thing here. So in 1 unit of chocolate, how much it will cost is rate of chocolate. Same way, in 1 second, how much change happens, that is rate of change. So dl by dt, what answer you will write? -2 or not? -2 meters per second or not? I hope all of you got this thing. Correct? All of you got it, no? So if you got it, answer this thing first. So I will use the same figure, just with different values. Suppose V1 is 10 and V2 is 6. V1 is 6, V2 is 10. So draw the diagram first in your head, that if you sit in the frame of A, with what velocity B will appear moving with what and in what direction, and tell me what will be dl by dt, everyone. So from the frame of A, I hope all of you agree that you will find B to be moving with 4, but in what direction? The rightward direction. So it means in 1 second, the distance between them is going to increase by 4 meters. So how much is the rate of change of L? Will be +4. All of you got this thing or not? Y +4, y -2. Clear to everyone? Any
Yes.
doubt? Okay, then I'll give few seconds to have a look, and I will take a new page. Once done copying, tell me, I will take a new page. Just because I'm going to share the recorded session of these classes, that does not mean that you should depend upon recorded session. That is for emergency only. Okay? That you were not able to come to the class, then only. But what is your job now is to come to class. If you can't come to class, what else you'll be doing in your life? So what is your duty to come to class? Okay, I will take a new page in case if anyone wants me to stay on this page longer, you tell me, or else I'll take a new page. Now, suppose if I have a case when relative velocity of one with respect to another is always perpendicular to the line joining them. So maybe I'll take some numerical example to make my point, to show you what really I'm talking about. Suppose at any moment it is given that A and B are having the solid velocities from ground frame.
நம்ம எல்லாம் வெளியே போய் லேட்டா வந்தவன காலையில போறேன் சாயந்தரமா போய்க்கிறாங்கிற அதுவும் இல்லாம பேட் எல்லாம் இருக்குல்ல அதெல்லாம் வந்து இங்கதான் இருக்குது. கார்ல போகும்போது ஒரு நாள் பண்ணி கொடுத்து எடுத்துட்டு போப்பான்னு சொல்லிட்டேன் நான். அதனால அதெல்லாம்
Mute your
இங்கதான்
mic, man.
இருக்கு. சாயந்தரம் போற மாதிரி இருந்துச்சுன்னா கொண்டு போய் கூட்டிட்டு வரேன்.
Don't know how to mute the mic, man. In case you're not using it, you mute the mic. Because it is getting recorded also now. Now, suppose it is given A is moving with, maybe I'll give velocity v1, that is suppose 6, and this angle is 37 degrees. Now velocity of B is v2 like that, and that is suppose maybe what to write, let me think, not 6, man, I'll give 10. Okay, so this one 10. So 10 into 4 by 5 is going to be 8, no? So I want something into 3 by 5 to be equal to 8. Then I will divide this 2. Forty by 3, no? 3 gone. Yes. So he is moving with 40 by 3. And this angle is 53 degrees. So what we will do first is, that is like common practice. You find the velocity of A and B along the line joining them and along the line along the direction perpendicular to the line joining them. And maybe for easy talking purpose, I consider this as X, this is Y at this given moment, just for this part of the problem. So the velocity of B has got one component, which is 40 by 3 into cos 57. No, so V2 cos 53. And what it is going to be? 40 by 3 into 3 by 5, that is 8. So same way, the component of V1 along X direction or along the line joining them is V1 cos 37. And that is going to be how much? 10 into 4 by 5, that is also 8. Now other component will be V1 sine 37, and that is going to be 10 into 3 by 5, that is going to be 6. And here I will have V2 sine 53, that will be 40 by 3 into 4 by 5, that will be how much? 8 for 32, so 32 by 3. So velocity of A is 8 I cap plus 6 j cap. Velocity of B is 8 I cap plus 32 by 3 j cap. Now if I ask you find velocity of B with respect to A, that will be VB minus VA. And when we do VB minus VA, the x components will be cancelled and net result will be in y direction. That will be 32 by 3 minus 6 j cap, and 32 minus 18, how much, man? By 3 will be, so 18 plus 2, 20, 14 by 3, no? 18 plus 10, 28 plus 4, 32, so 14 by 3 j cap. Now, just for understanding purpose, I am considering that velocity of b with respect to a, suppose, never changes. Suppose it is constant. Then what kind of thing is going to be happening that we will talk about? That is not of this chapter. Just to make you understand something, I'm talking about it. In circular motion, such thing we are going to come across. So what kind of thing I have? That A is fixed now. So from A's frame, I'm writing down the things. A is fixed. And I find B to be moving with some velocity along y direction. So he is moving with some velocity which is perpendicular to the line joining A and B. So it is moving with some velocity which is 14 by 3. That is what really came out to be the velocity of B with respect to A. Now tell me, in this case, do you think the separation between A and B will change? What kind of motion B is seen having now? It is neither going towards B, no? So in this case, by sitting in the frame of A, I find B moving towards A. By sitting in the frame of A, I find B moving away from A. Because the velocity of B with respect to A was having a component, or it is in the direction which is the direction of the line joining them, no? So here it is having something along line joining them, here it is having something along line joining them. So due to that, separation between them was changing. Now in this case it has got nothing along the line joining them, so the point B is not moving towards A, and he is neither moving away from A. So what really he is doing is going around A. After some moment, you will realize that point B will be reaching here. So literally, you disconnect it yourself from the earlier part of the question. A and B not both are not moving now. Only B is moving. A is fixed. Then we are applying some logical reasoning. No, got the point? No, don't mix up or confuse yourself by thinking both are moving. No, when I sit in the frame of A, literally I am solving a brand new question in which A is the fixed point and B is the only moving point. So what kind of motion the B has got around A is it is always going in a direction perpendicular to the line joining them. So because of that, B goes around A, neither it is moving towards A, neither it is moving away from A. So what will be the rate of change of separation between the point A and B in such situation, you will say, will be 0 or not? So in this case, point B goes around A as if A is the center of the circle, A the center of the circle whose radius is equal to AB, and B travels and B undergoes circular motion. No? So it is going to be same thing as if A is the center of the circle whose radius is equal to L, which is not changing, and B going around in a circular path, A being the center of the circle. So what is the distance between A and B in such situation will be not changing. So rate of change of separation or the distance between them will be zero or not. This thing all of you have understood. So always the B has got velocity perpendicular to the line joining AB. So it is neither moving towards A, neither moving away from A. So obviously the distance between AB will not be changing. Clear now? I hope this point is clear to all of you. Clear now, man? Anyone having any doubt, I'll explain again. Clear or not clear, just you must take it like a fact, even though that the component that velocity of B with respect to A, if it is perpendicular to the line AB, then the distance between A and B will not be changing. Okay. Okay, I can take a new page now. I can take a new page.
Yes, sir.
We will do something having numerical values, then I will give you some standard looking result. But understanding is more important. So at any moment, it is given A is moving with V1 and V2 as shown. And the job here I have to do is to find the rate of change of separation between them. So every time process remains the same, find the component of the velocity of each one along the line joining them and in the direction perpendicular to the line joining them. This is X, this is Y. So component of V1 are going to be this two, and V2 are going to be again this two. Find that thing out, everyone first. Or maybe I'll do it, nothing much in here. So cos 37 is 4 by 5, so this is going to be 8. Sine 37 is 3 by 5, so that will be 10 sine 37, and that is going to be 6. So 20 cos 53, cos 53 is 3 by 5, so 20 into 3 by 5, 12. And 20 into sine 53, that is 4 by 5. So 20 into 4 by 5 will be 60. Just for easy understanding purpose, I consider this as x and this as y. So velocity of A will be 8 I cap plus 6 j cap. Velocity of B will be 12 I cap plus 16 j cap. So find the velocity of B with respect to A. That will be 12 minus 8, 4 I cap. 16 minus 6 plus 10 j cap. After that, you literally think A is fixed, B only moving, but moving with 4 along plus 6, 10 along plus 5. By being in the frame of A, I will find B to be moving with 4 along plus x direction and with something along plus y direction. Literally, we are thinking A is fixed, B is only moving. So this is our 4. But violet or purple, what color it is, I forgot, man. This is suppose this is our 10. So tell me, due to this component, the one which was the only component in this case. In this case, VBA was in the direction which is perpendicular to the AB. What is the job VBA was doing? It was making B to go around A without causing any change in the separation between them. So in this case, VBA was only in the direction perpendicular to AB. In this case, VBA are in the direction which is along AB. So along AB are the along AB component is the one which is responsible for changing the separation, no? Correct? So even when both the components present, the job of each component doesn't change. Okay. Teacher, student both present in the class, so job of teacher will be same, job student will be same, no? It's not a good example, but still. So even though when both the components present, what job each component does, due to this component, separation is not affected. What kind of thing B does because of this component of the velocity it has got? Due to this, it goes around, and this is the one which is responsible for changing the separation between them. So you think only this black component present, think this purple one not there at all. So if only this black one present, then what really I have got a case where B is moving away from B with how much? Sorry, B is moving away from A with how much? 4. So what must be the rate at which the separation between them is changing? You can totally find out. So that dl by dt is going to be equal to plus 4. I hope all of you got this thing. So maybe you don't worry about this component at all as if it is not there. Then you can totally solve this question. It is going to be something which is belonging to on either this category when separation decreases or can be this category when separation increases. So this question dl by dt will be same as this question dl by dt. This one not going to affect the separation between them. I hope it is clear to all of you what must be done when the component of VA and VB velocities, the component of velocity of A and B is given like that, maybe clear, no? So now I will write them general result to copy this thing in case if you're copying. I'll take a new page. Okay, I'll take a new page. This is VA. Maybe we'll write VA headed. I'll write V1 having an angle theta 1 with the line joining them. Velocity of B is V2 having an angle theta 2. So the component of V1, V2 along the line joining them and perpendicular to the line joining them we will find. And those are going to be V1 cos theta 1, V1 sin theta 1, V2 cos theta 2, V2 sin theta 2. Now, if I sit in the frame of A, maybe I will write the final result directly. In case if you don't get it, you tell me. Then I will explain that steps. So by being in the frame of A, I will find B to be moving with V2 cos theta 2 minus V1 cos theta 1 along the line joining them, and will be seen moving with V2 sin theta 2 minus of V1 sin theta 1 in the direction which is perpendicular to the line joining them. This is our A and this is our B. So this component of the velocity, I'll be giving it the name V parallel. See, double bars means parallel. R stands for relative. And this component, I'll be naming him as V perpendicular relative. And these two components are the components of the velocity of B with respect to A. So by being in the frame of A, I will find the velocity of B with respect to A must be somewhat like this. Now, the rate at which separation between them is changing will be equal to V2 cos theta 2 minus of V1 cos theta 1. So if V2 cos theta 2 is more than V1 cos theta 1, dl by dt will be positive. Means separation is increasing. If V2 cos theta 2 minus V1 cos theta 1 is negative, it could be, then it means this component is not in left rightward direction, instead it is in leftward direction. And that is going to be a case when the distance or separation will be decreasing. So this earlier case, this case is the case when V2 cos theta 2 is 12, V1 cos theta 1 is 8. So V2 cos theta 2, 12, bigger than V1 cos theta 1, which is 8. What I find, B moving with 4 in the direction which is away from A. In case if it was reverse, or if it was a case V2 cos theta 2 is lesser than V1 cos theta 1, then the velocity of B with respect to A along the line joining them will not be away from A, it's going to be towards A, no? So I hope this point is clear to everyone. So one result I will write, no questions will be asked from there because we have not started circular motion. Just for these two things comes together, so I'm telling that one also here itself. So tell me, if I ask you, due to this velocity component of B with respect to A, which is perpendicular to the line joining them, due to this, B will be going around A, but in what sense B will be going around A? This sense, no? Correct? So the angular velocity, so this is omega, means angular velocity of B with respect to A is going to be given by that V perpendicular relative divided by whatever the separation they have between them, that is L. Just write down this result. No use of this result we are going to have. And when circular motion starts, there we'll be discussing it in detail why omega or angular velocity will be like that, because we have not even talked about what is angular velocity. So omega b with respect to a is it is angular velocity of b with respect to a. At what rate the angular position of b with respect to a is changing, that you can understand, take it like that. So I hope this thing is clear to all of you, how to figure out the rate of change of separation between two moving particles. Before telling the result, we have done the solved examples. No? Okay, copy this thing, then I will give one simple solved example just to check whether you understood or not. This component is responsible for making B to go around, Due to this, B goes around A, and only due to this, okay, I can take a new page.
Yes,
Menu. Okay. Similar question, you don't have to do more calculation. Whatever I gave, same thing I'll give, just in reverse manner. B2 is 20, this is 53. B1 is what B2? Just a moment. A is moving with V1, that is 20, and this one is 53. B is moving with V2, that is 10, and this is 37. Find the rate of change of separation between them. The other case that we have done already, I will write down that also. Just have to make some point. V1 is 10, V2 is 20. So find out for first case what is dr by dt. Everyone pass first. Same values I'll copy. 20 cos 53, 12. So 12, 8, 6, 16. 12, 8, 6, 16. So it's going to be 12. So in first case, if I sit in the frame of A, in second case, I will do that as done already. I want to make some point through this thing also. So what we find, the velocity of B with respect to A, one component is 4, other component is 6, like 10, no? So one component is 4 and this component is 10. This is A and this is B. So the relative velocity, which is the velocity of B with respect to A, is in this manner. In this case, if I sit in the frame of A, what you find that B will be moving towards A with how much? 4. And B is moving in minus y direction or with 10 like this, no? Because 6 minus 16 you do, you get minus 10. So in this case, the velocity of B with respect to A is somewhat like this. So in this case, what answer you will write? dr by dt is going to be how much? Minus 4, no? In this case, what dr by dt will be equal to? Plus 4. All of you agree to this point or not? All of you got it now? How we have
Yes,
got okay. So why 10 came down, that also you understood, no? Okay, then now, in this case, tell me, what is the way the arrow of velocity of B with respect to A is? So velocity of B with respect to A is making an acute angle with AB, no? So if I have a vector VBA, which is drawn like this, his component along AB is in what direction? Towards A. In this case, this angle is obtuse, or in this case, the component of the relative velocity is along the line joining them is in what manner? Away from A, no? So this component is towards A, and in this case, this component is away from A. Correct? So dr by dt, you got that both the cases. Now I will draw different scenario, and you tell me in what case separation is increasing and in what case the separation is decreasing. So in this case, you realize no what really the velocity of p with respect to a will be somewhat in this direction. So if a vector drawn like that, it's going to have a component along the line joining a and b, but that component is which way? Towards a. So if I draw a vector like this red one, it has a component along AB, but which way that component is? Away from A. So in this case, separation increases. In this case, separation decreases. So I'll take a new page in case if you want me to return back to this slide, you tell me. So I'm observing an object from the frame of another object, and I find this is A, this is B. Case 1, I find velocity of B with respect to A or V relative to be perpendicular to AB. Just a moment. Now next case, velocity of B with respect to A is like this. Velocity of B with respect to A is like this. Velocity of B with respect to A is like this. And velocity of B with respect to A is like this. So in every case, you comment on what is the air by dt, positive, negative, or maybe 0. Case 1, you got it. In this case, dr by dt, what d, sometimes I use r instead of l. So in this case, dl by dt is equal to how much? 0. So in this case, the component of the relative velocity, if I will find, that will be in this direction, no? In this case, if I find the component of the velocity along line joining them is this way. In this case, I find component of that black arrow will be this way. In this case, if I find the component of the black arrow along line joining A and B will be this way. So in this case, the relative velocity has a component directed away from A. In this case, relative velocity has a component directed towards A. In this case, that relative velocity is having a component directed away from A. So maybe I'll give some values also. Suppose this angle is phi. This angle is alpha. This angle is theta. This angle is theta alpha. I'll cut over, man. This angle is maybe again alpha. So can you write what will be dr by dt? And if B relative is of magnitude V. So see here I was given A and B in terms of the components. So I found out velocity of B with respect to A in terms of the components. But data can be given to you in different manner. Maybe I tell you VB a vector is of this length and this angle tool. So using the VBA vector length and the angle, you can find what all components the sky will have along the line joining them and along the line or along the direction perpendicular to the line joining them. So in this case, what is the component VR has got along the line joining them? V cos phi, but away from A. And don't worry about that perpendicular component. I'm asking you, find the rate of change of distance between them. Same here, I've given you VR is V. So component along the line joining them is V cos alpha. Component along the line joining them here will be V cos theta. In this case, it will be again V cos alpha. So whatever I'm writing, correct or not, you check. What dr by dt in this case will be plus or minus? Plus, but what plus? You find him moving with this many speed, but in a direction directed away from A. So separation increases and the rate of change of separation between them will be plus V cos phi. In this case, dl by dt will be minus V cos alpha. In this case, dl by dt will be plus v cos theta. In this case, dl by dt will be minus v cos alpha. I hope all this case is clear to all of you. Clear, no?
Yes, sir.
Okay, then I'll give some homework, and it is very essential to try that homework thing today only. Today you will try, then only you will be able to solve some of them at least. See, I'm giving homework does not mean that you will be able to solve. Maybe sometime I give homework knowing that no one will be able to solve. So how to open both of them, and homework is exercise homeworks I will write first. Exercise 1, not much I can give also. Question number 7, question number 8, question number 13, question number 15, question number 17, question number 18, question number 20, 21. Exercise 2, question number 3. 3, don't waste more time, but try once, okay? Then question number 8, exercise 3, question number 3, question number 8, four A, question number 2, question number 3, question number 4, question number 5, question number 7, 4B, question number 2, then beginner boxes. Beginner boxes 1. I don't have the beginner box with me, so no beginner box homework, but this much you must try. So next backup class we will discuss the doubts and we will do the next thing. Maybe next backup will happen on Saturday, maybe for weekdays. In between weekdays, I take for weekend also. So I will share that recording also. Okay. Okay then, bye everyone. I'll share this thing.
Okay, sir. Thank you, sir.
Okay then, I'll end the class now. Bye bye. My iPad battery also over. After the class, you take some break and then copy it also.
Sir, please upload the recording also, sir.
Yeah, I'll upload the recording, but it gets available after 1 hour or something. Yeah. Okay, bye everyone. I'll end the meeting.